Today we're going to take a look at fractions. The numerator is the top part of the fraction. It's the number of parts that you have. The denominator is the bottom of the fraction. It's the number of parts the whole is divided into. Let's take a look at some pictures. If you look at the circles, you'll see that at first there's 1 out of 1. You have one part out of one whole circle. But then as we cut the circles into more pieces, the denominator, the bottom part, keeps getting larger, but each piece is smaller. So if we look down here, the denominator is 5. That means that we've broken up the circle into 5 pieces. You only have 1, so 1 out of 5. If we come all the way over here, we have 1 out of 10. If you only have 1 out of 10, you have a very small piece of pie. The larger the denominator, the more pieces there are, which means each piece has to be smaller. Moving on to equivalent fractions. We have 4/8, 2/4, and 1/2. If you look at the pizza, we can see that you have half a pizza no matter which way you look at it. But if the pizza originally had 8 pieces, that means you have 4 pieces left. If the pizza originally only had 4 pieces total, that means you have 2 out of the 4 pieces. And if you're just looking at the whole pizza pie, you only have 1/2 of a pizza. These are called equivalent fractions. When do we need to know equivalent fractions? We need to talk about them when we're reducing or simplifying fractions. To reduce a fraction, you're simply taking out all of the common factors. One easy way of doing it is go with the smallest factor that you know. Well, I know that 4 and 8 are both even numbers, which means we can divide the top and the bottom by 2. 4 divides by 2, 8 divides by 2. That gives me 2 over 4. But 2 over 4 are still even numbers. So again, I can divide by 2, which is going to give me 2 divided by 2 is 1 over 2. Now, if you knew your multiplication tables, you would see that, hey, 4 and 8 are both divisible by 4. So if I had the original question, 4 over 8, then I could have divided both the top and the bottom by 4, which is going to give me 1/2. It's the same way. Key part to remember is whatever you do to the top, you also do to the bottom. So if I come down to 6 over 18, well, I know that 6 and 18 are both even numbers, so I can divide it by 2. Divide by 2, divide by 2. Whatever I do to the top, I do to the bottom. 6 divided by 2 is 3. 18 divided by 2 is 9. But wait a second. 3 and 9 are both divisible by 3. So I divide by 3, I divide by 3, and that's going to give me 1/3. Now, some of you have seen that 6 and 18, I could have just divided by 6, and that would have given me the same number. So whether you have to go in small steps or you can go in a little bit larger steps, that's perfectly fine. Now, if you look at 21 and 63, you're wondering, well, what can I divide both of those by? One trick that you can use is simply add them up. What is 2 plus 1? Well, 2 plus 1 is 3. What is 6 plus 3? Well, 6 plus 3 is 9. I know that 3 is divided by 3, and I know that 9 is divided by 3. How does this help me? Well, it tells me that 21 and 63 are both divisible by 3. So that means I can divide by 3 and divide by 3. Whatever I do to the top, I do to the bottom. 21 divided by 3 is 7. And 63 divided by 3, well, 6 divided by 3 is 2. 3 divided by 3 is 1. Now, hopefully you see that 7 and 21 are both divisible by 7. So I can divide both by 7. And that's going to give me 1/7. If you had stopped at 7 over 21, you would have gotten the problem wrong because that is not in simplest form. We always have to reduce all the way. Now, 21 and 48. Off the top of my head, I don't know what goes into it. I know that 21 is divisible by 3 and 7 because that was in the last problem, but not necessarily 48. So I'm going to use the trick again. I'm going to see 21, 2 plus 1 is equal to 3, and 48, 4 plus 8 is equal to 12. Well, I know that 3 and 12 are both divisible by 3. That means I can come back to my problem and I can reduce by 3. Whatever I do to the top, I also do to the bottom. 21 divided by 3 is 7, like we just said. 48 divided by 3, if you're not sure what it is, come off to the side and do the math. 48 and 3. 3 goes into 4 one time, with 1 left over. Bring down the 8. 3 goes in 18 6 times. That leaves me with 7 over 16. 7 and 16, there's no numbers that go into both of them, so I am finished with that problem. If you're not sure what to reduce by, write down the factors. 35, I know that's 5 times 7, and 14, I know that's 2 times 7. So that tells me that they have a 7 in common. So what I'm going to do is first get rid of my little notes, and then I'm going to reduce the top and the bottom by 7. Whatever I do to the top, I do to the bottom. 35 divided by 7 is 5, and 14 divided by 7 is 2. Now, the bigger number is on top. Sometimes it's okay, sometimes it's not. If you're going to change that to a mixed number, then you ask yourself, 2 times what is really close to 5? Well, 2 times 2 is really close to 5. So 2 times 2. Well, 2 times 2 is 4. So 5 minus 4 is 1 left over. And if that didn't make sense to you, you can always do this. 5 being divided by 2. 2 goes into 5 2 times. That's a 4. Subtract by 1. And that gives me 1 over 2 left over. Moving on to adding or subtracting fractions. The first thing you're going to have to do is find a common denominator. You can do this by factoring and seeing what terms are the same. And you can use the least common multiple if needed. Go and search one of my least common multiple videos. Add or subtract the numerators only. You don't change the denominator once you have those common denominators. When you're finished, always look to see if you can simplify the problem. So let's look at the pizza again. If you have 1/4 of a pizza and you have 1/4 of a pizza, that means you have 2 quarters. So 2 over 4. Now, if you look closely, I can see that 2 over 4 can be reduced, like we were just doing, and that means you have half of a pizza. What if the pizza was cut into smaller pieces? I have 5 out of the 8 pieces that were in the pizza, and then I have 1 other piece left over. So I'm only adding the numerators. 5 plus 1 is 6. That leaves 6/8 of a pizza. Again, I can reduce by 2, and that's going to give me 3/4 of the pizza left over. Always leave your answer in most simplified form. Let's do a couple problems. You must have common denominators. That's always your first step. We can factor if needed. If you're totally stuck, you can use the least common multiple. If I look at 2 and 6, I'm going to ask myself, what do I have to multiply them by to get them to be the same number? I know that I can multiply the 2 by a 3 to get it to equal 6. Whatever I do to the bottom, I do to the top. What that gives me is 1 times 3 is 3 over 6 plus, now I didn't have to change the other fraction, so I'm leaving it the same, 5 over 6. Next, add or subtract the numerators. We're going to leave the denominator alone. Now, one trick for making sure you leave that denominator alone is, since you have a common denominator, I only need to write it once. That's going to give me a 3 plus 5 on top. 3 plus 5 is equal to 8. And we did not change that denominator. Next, we're going to simplify. Well, I know that 8 is divisible by 2, and I know that 6 is divisible by 2. And so that gives me 4 over 3. Now, sometimes an improper fraction is okay, but sometimes you need to use a mixed number. Ask yourself, 3 times what number goes into 4? Well, 3 times 1 goes into 4 with 1 left over. So I have 1 and 1/3. Let's do another example. 1/3 plus 2/5. I can't simply multiply one of the numbers to make a common denominator, so I'm going to have to multiply both of them. What is the smallest number that 3 and 5 both go into? Well, 15. So I'm going to have to multiply the 3 by 5. Whatever I do to the bottom, I do to the top. I'm also going to have to multiply the 5 times the 3. Whatever I do to the bottom, I do to the top. That gives me 5 over 15 plus 2 times 3 is 6, and that's over 15. Again, we can use a single line fraction now. So I have the 15 with the addition problem on top. 5 plus 6, that gives me 11 out of 15. Now, we always try to reduce if possible. However, here, 11 is a prime number, which means it can't be reduced. It's not an improper fraction, so I can go ahead and leave it 11 over 15. Okay, a few more problems. I have 6 and 14 as common denominators. Notice this is also a subtraction problem. What number does 6 and 14 both go into? Well, I know 14 times 1 is 14, 14 times 2 is 28, 14 times 3 is 42. Now think of the factors of 6, or the multiples of 6. 6 times 1 is 6, 42. Now, if you know your multiplication tables right off the bat, you don't have to make the long list. If you're not sure about your multiplication tables, then go ahead and make the list. It'll work. Now I need to figure out what I had to multiply by. I know that this was 14 times 2 to get the 42. Whatever I do on the top, I also do to the bottom. And that is 6 times 7 to get the 42. Whatever I do to the bottom, I also do to the top. Now, especially for a subtraction problem, I'm going to change it to one single denominator, which is 42. Minus sign in the middle. 7 times 1 is 7. 3 times 2 is 6. 7 minus 6 is simply 1 over 42. And we are finished. Moving to the right, now I have 10 and 4. So I'm going to multiply the 10 times 4, and I'm going to multiply the 2 times 4. I'm going to multiply the 4 times 10, and whatever I do to the bottom, I have to do to the top. That's going to give me a common denominator of 40. And negative, don't forget your negative signs. Move those up onto that number. Negative 2 times 4 is a negative 8. Negative 3 times 10 is a negative 30. Negative 8, negative 30. They have the same signs. That means we're simply going to add them up, which is 38, and keep the sign, a negative. We have negative 38 over 40. Now they're both even numbers, so I can go back and reduce. I can divide the top by 2. I can divide the bottom by 2. And that's going to give me negative 19 over 20. Now, if you do have to reduce at the end, it probably means that we used too big of a number to begin with. So the easy way was, well, I know 4 times 10 and 10 times 4. That was easy. But we should also have realized that we could have had a common denominator of 20. So to rewrite my problem, now instead of using the 4, I could have used times 2 on top and bottom, and then times 5 on top and bottom. By doing this, I wouldn't have had to reduce at the end. That would give me a negative 4 minus 15 over 20, which gives me a negative 19 over 20. So if you use a number that's a little bit too big, that's not a problem. Just reduce before you get to your final answer. Or use the proper numbers to begin with, and you won't have to reduce at the end. Okay, let's move down to some mixed numbers. I have 2/5 plus 2 and 3/4. Now mixed numbers don't add and subtract very well. What you want to do is change it to an improper fraction. The way we do this is simply multiply 4 times 2. Well, 4 times 2 is 8. And then you're going to add. So you're multiplying and then you're adding. 4 times 2 is 8, plus 3 is 11. The 2/5 didn't change, plus 11 over 4. The new number is on top. Now I need those common denominators. Well, I know that 5 times 4 is 20, so times 4, whatever I do to the bottom, I do to the top. And then 4 times 5 is 20, so whatever I do to the bottom, I do to the top. That's going to give me my common denominator of 20, and then 2 times 4 is 8. 11 times 5 is 55. Now I have a really big number. 8 plus 55 is 63. 63 over 20. Now to change that back to a mixed number, ask yourself, how many times does 20 go into 63? 20 goes into 63 3 times. 3 times 20 is 60, and I have 3 left over. Gives me 3 over 20. 3 over 20 does not reduce, and I am finished. One more over here on the right. 5 times 3 is 15, and then 3 plus 4 is 19. Notice, ignore that negative sign to begin with. I'm still multiplying 3 times 5, and I'm still adding the 15 plus 4. Over here on the 1 and 2, 2 times 1, that's times, and then I'm adding. So 2 times 1 is 2, plus 1 is 3 over 2, minus 5 times 3 was 15, plus 4 is 19 over 5. My least common denominator for these are going to be 10. So I'm going to multiply this times 5. What I do to the bottom, I do to the top. And this times 2. What I do to the bottom, I always do to the top. That gives me a common denominator of 10. 3 times 5, 15. Subtraction symbol, minus 2 times 19, 38. Now if you need to, you can go ahead and do a little side problem. 38 take away 15. 8 take away 5 is 3. 3 take away 1 is 2. Go back and look. Who's bigger, the 38 or the 15? Well, the 38 is bigger, so that means he's going to keep his sign, and we're going to have a negative 23 over 10. Ask yourself, how many times does 10 go into 23? It goes in 2 times with 3 left over, and it was a negative problem. Now moving on to something much easier, multiplying fractions. All you have to do is multiply straight across and look to reduce. The numerator multiplies times the numerator, and the denominator multiplies times the denominator. When you're finished, always try to reduce. I have 2/3 times 4/5. I'm going to multiply directly across. The 2 times the 4 is 8 over the 3 times the 5 is 15. Look to see if I can reduce. Nothing goes into both numbers, so I have an answer. Over here, I have a negative 4 times 3. Well, a negative times a positive is a negative. So that gives me negative 12 over, and again, I'm multiplying straight across. 5 times 7 is 35. Now, if possible, you try to reduce before multiplying to make the number smaller and easier. Only when multiplying can you cross cancel. So if I have 2 over 9 and 5 over 6, before I get started, I can reduce the 2 and the 6. I can reduce both by 2. So 2 divided by 2 is 1. Cross it out. And then 6 divided by 2 is 3. Always cross out the number and write the new number underneath. Now just multiply straight across. 1 times 5, 1 times 5, over 9 times 3, 9 times 3. Well, 1 times 5 is 5 over 27. Next, 8 over 12 times 9 over 24. We always try to reduce first. I can see that 8 and 12 can both be reduced by 4. So 8 divided by 4 is 2, and 12 divided by 4 is 3. Next, I can see that 9 and 24 can both be reduced by 3. So 9 divided by 3 is 3. 24 divided by 3 is 8. But I'm not finished. I can cross cancel now. The 2 and 8 are both divisible by 2. The 2 divided by 2 is 1. 8 divided by 2 is 4. Always make sure you put the 1 there. Next, 3's. 3 divided by 3 is 1. 3 divided by 3 is 1. That leaves me with 1 times 1 over 1 times 4. Well, 1 times 1 is 1. 1 times 4 is 4. And I don't have to reduce the end because I've already simplified my fractions. A few more examples. Remember to cross cancel before we even start. I have 2 over 5 doesn't reduce, but 2 and 4 can reduce. So 2 divided by 2 is 1, 4 divided by 2 is 2, 5 divided by 5 is 1, 5 divided by 5 is 1. Always put those numbers there, even if they're 1. That leaves me with 1 times 1 is 1, 1 times 2 is 2, and I'm finished. 10 over 6 times 3 over 2. Well, the 3 and the 6, that's pretty obvious. The 3 becomes a 1, and 6 divided by 3 is 2. Next, I can do the 10 and the 2, or you can do the 10 and the other 2. Doesn't matter, that's completely up to you. I'm going to go top and bottom. That gives me 5 over 1. Now multiply them straight across. 5 times 1 over 1 times 2. That gives me 5 halves. Sometimes an improper fraction is okay, sometimes it's not. We ask ourselves, how many times does 2 go into 5? It goes in 2 times. How much is left over? There's 1 left over. So we have 2 and 1 half. Now, what if you have a whole number times a fraction? Here's a little secret. There is no such thing as a whole number. All numbers, even if they're considered whole, are fractions. They're over an invisible 1. So whenever we're multiplying a fraction times a whole number, change that whole number to a fraction. Simply write the invisible over 1. Now you're going to multiply straight across, unless you can reduce first. I see that I can reduce the 15 and the 12, both by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. Now I can multiply straight across. 5 times 7 is 35. 1 times 4 is 4. 4 goes into 35 8 times, with how much left over? 3 over 4 left over. And again, on the right-hand side, I have the 4 sitting there. Never a whole number, always a fraction. Write the invisible 1. Look to see if we can cross cancel. I see that 4 and 26 can cancel out to give me 2 over 13. 26 divided by 2 is 13. Now we're going to multiply straight across. 9 times 2 is 18. 13 times 1 is 13. We can change that to a mixed number. 13 goes into 18 only one time, and we have 5 over 13 left over. Moving on to dividing fractions. Stop. You will never, ever divide fractions. Never. Just in case you need to see it again, you will never divide fractions. Before we get into what you actually do, let's talk about some vocabulary. First off, a reciprocal. What is the reciprocal? It's a number that's been flipped. So if I have 2/3 and I take the reciprocal of 2/3, I'm left with 3 over 2. We're simply flipping these numbers. The reciprocal of 1 over 4 is 4 over 1. I simply flipped it over. What about the reciprocal of 5? I thought 5 is a whole number. Don't forget about the invisible numbers. 5 over the invisible 1. And that becomes 1 over 5 when I take the reciprocal. So how do we divide fractions? Well, we don't. What do we do instead? We invert and multiply. What's invert? It's the reciprocal. It means to flip it over. So let's take a look at some examples. I have 4/5 divided by 7 over 9. The 4/5 is going to stay the same. I'm going to leave it 4/5. Then I'm going to say times, and you take the reciprocal of the back number. That becomes 9 over 7. Now you do everything we did in multiplication. Can I cancel or reduce? No, so I'm just going to multiply. We multiply straight across. 4 times 9 is 36. 5 times 7 is 30. 35 goes into 36 one time, with 1/36 left over. Next, 2/3 divided by 3/4. Some of you are going to say, hey, I can cancel those out. No, you can only cross cancel in multiplication, not in division. What do you do in division? You invert and multiply. The 2/3 stays the same. You write the times symbol, and then you invert this, 4 over 3. Now I look at it, and there's nothing to reduce or cancel, so I'm going to multiply straight across. 2 times 4 is 8 over 9. And we are finished with that one. Now, if we look at the problem over there on the right, it's written a little bit differently. If it's written like that, change it so that it looks more normal. What it's saying is 4/5 divided by 6/7. So I'm going to rewrite it 4/5 divided by 6/7. It's a lot easier to see this way. Now do the same thing. Invert and multiply. So 4 over 5 times 7 over 6. Before I multiply this, I can cross cancel. The 4 can become a 2, and the 6 will become a 3 because I reduced them both by 2. Now I'm going to multiply straight across. 2 times 7 is 14. 5 times 3 is 15, and I have my answer. What if they give you a whole number? 5 divided by 3/4. Remember, 5 is a fraction. It's over the invisible 1, so nothing changes. I have 5 over 1 times, and we're going to invert the 3/4. 4 over 3. There's nothing to cross cancel, so I multiply. 5 times 4 is 20 over 3 times 1 is 3. How many times does 3 go into 20? Well, it goes in 6 times. That gives you 18. And that means you have 2 out of the 3 left over. One more problem here. I have 7/8 divided by 15. So like I said before, break it up. 7/8 divided by 15. But wait a second, that's a whole number. Don't forget your invisible 1. Make it visible. So now I have 7/8 divided by 15 over 1. That makes a little more sense. Invert and multiply. 7/8 times 1 over 15. Look to see if we can cancel anything. Nope. So we just multiply straight across. 7 times 1 is 7. 8 times 15. If you're not sure what that is off the top of your head, break it up. 8 times 10 is equal to 80. And then 8 times 5 is equal to 40. 80 plus 40 is 120. So your answer is 120. I have one last problem for you here. 7 over nothing. No, it's invisible. 7 over 1. Invert and multiply. 2/3 times 1 over 7 gives me 2 times 1 is 2. 3 times 7 is 21. Remember, we never, ever divide fractions. We always invert and multiply.